Hello, today's video is going to cover multiplying matrices. When we multiply matrices, they can only be multiplied, it says they can be multiplied if and only if the number of columns in A equals the number of rows in B. So if matrix A has dimensions m by n, and matrix B has dimensions n by p, then the resulting dimensions of AB is m by p. So I want us to look at this. This is saying that a matrix m by n times n by p equals m by p. So in order to be allowed to multiply these two numbers have to be the same, and then the outside numbers become the dimensions of the new matrix. For these first few problems, it just wants to know about whether or not we can multiply the matrices and the dimensions of the resulting matrix. So if we had A times D, A is a 4 by 3 matrix, and we would be multiplying it by D, which is a 3 by 1 matrix. These two numbers are the same, so we can multiply these together, and it's going to give us a 4 by 1 matrix. So the inside values have to be the same, and the outside values give us the new dimensions. So for number 2, we're using A again. So technically your answer to this one would be yes, 4 by 1. But I can also see that from just this. So AC is a 4 by 3 matrix times a 2 by 4 matrix. These are not the same. So your answer is just no. This is not possible or not defined. Okay, so how do we actually multiply matrices? We're going to read through this and then we're going to try to put it in simpler terms. The element in the mth row and the nth column of matrix AB is the sum of the products of the corresponding elements in row M of matrix A and column N of matrix B. Show this pattern below. Okay, so what I want to show you is kind of going to look like what I've done down here. We have a 2 by 2 matrix times a 2 by 2 matrix. These are the same, so we can multiply them, and our answer will be another 2 by 2 matrix. So we're going to start by making a bracket, and we're going to have 4 spots here. It's a 2 by 2, so there will be 4 elements. The first element is going to be row 1 times column 1. So its position in, this is what our answer will look like. And if you notice, whenever we talked about, like, for example, this term, this element, would be A11 because it is row 1, column 1. Well, whatever position that is, those are the rows and columns you multiply together to get it. So for the very first element, we do not care about row 2, and we don't care, that's column, sorry. We don't care about row 2 and we don't care about column 2. We only want to multiply row 1 times column 1. So when we do that, we're not distributing, we're multiplying the corresponding elements. So that sounds kind of funky, but what it's going to be is we're going to have A times E, and then we're going to add to that B times G. That's our first element, our first term in this matrix. So now I'm going to go back and I'm going to erase our marks that we made over that. So if we want to fill in this term in our answer is row 1, column 2. So we are going to multiply row 1, so we don't care about this one, times column 2, so we don't care about that one. So this term, this element, is going to be AF plus BH. Okay, so let's erase these again. Now we want to multiply to get this one, row 2 times column 1. So row 2 times column 1. That's going to give us CE plus DG. And then our last one is in the position of row 2, column 2. So we don't care about row 1 or column 1. We're going to multiply row 2 times column 2. So that will give us CF plus DH. So this is the generic form of multiplying matrices. Let's do number 9 together as an example. We have a 2 by 2 matrix times a 2 by 2 matrix. These are the same, so we can multiply them, and the answer is going to be another 2 by 2 matrix. So I'm going to go ahead and put equals in a bracket. So remember, to find the first term, we are going to have row 1 times column 1. So again, just to help us stay straight, I'm going to mark out the ones we're not using. Row 1 times column 1 is going to be negative 4 times 6, which is negative 24. And then negative 9 times negative 5 is positive 45. All right. Then we're going to do row 1 times column 2 to get row 1, column 2. So negative 4 times negative 1 is positive 4. Negative 9 times 4 is negative 36. All right, next element. Let's do row 2, column 1 to give us row 2, column 1. 3 times 6 is 18. Negative 2 times negative 5 is positive 10. Then we're going to do row 2, column 2 to give us row 2, column 2. 3 times negative 1 is negative 3. 4 times negative 2 is negative 8. So then we just have to simplify what we've got here. Negative 24 plus 45 is going to give us 21. 18 plus 10 is 28. 4 minus 36 is negative 32. And negative 3 minus 8 is negative 11. So there is our answer for this problem. I'm going to do a few examples of these because they are kind of a confusing process to wrap your head around for sometimes. So if you feel like you understand, you're welcome to move ahead in the video to the word problem portion, but I want to work out a few more examples for those that feel like they don't understand yet. All right, this is a 2 by 3 matrix times a 3 by 1 matrix. Oops. So 3 and 3, those are the same. Our answer is going to be a 2 by 1 matrix. So let's come up here. So we're going to have 2 rows and 1 column. So to come up with row 1, column 1, we need to multiply row 1 times column 1. So we don't need row 2, and there is no other columns. So negative 7 times negative 6 is positive 42. 2 times 4 is positive 8. Negative 11 times negative 3 is positive 33. Now for row 2 times row 1 or column 1, we're going to get 3 times negative 6, which is negative 18. Negative 5 times 4 is negative 20, and negative 2 times negative 3 is positive 6. When we add these together and simplify it, we are going to end up with 83 and negative 32. And that's our answer for this problem. Okay, another example, number 13. This is a 2 by 2 matrix times a 2 by 3 matrix. The middle two numbers are the same, so we can multiply this to get a 2 by 3 matrix. So it's going to be 2 rows, 3 columns. So to get row 1, column 1, we multiply row 1 by column 1. So 9 times negative 3 is negative 27. Negative 5 times negative 1 is positive 5. All right, to get row 1, column 2, we're going to multiply row 1 times column 2. So 9 times 13 is going to give us 117. And then negative 5 times negative 7 is positive 35. Then to get the third one in the top row, we're going to do the top row times the third column. So 9 times negative 5 is negative 45. Negative 5 times positive 2 is negative 10. So now let's move to row 2. So we don't care about row 1 anymore, and we'll start with column 1. So negative 2 times negative 3 is positive 6, and 4 times negative 1 is negative 4. Then we want to do column 2. So negative 2 times 13 is negative 26. 4 times negative 7 is negative 28. Now let's do column 3. Negative 2 times negative 5 is positive 10, and 4 times 2 is positive 8. So then once we simplify each element, we're going to get negative 22 2. We're going to get 152, negative 54, negative 55, and 18. And that is our answer for this problem. So now I want to talk about properties of multiplication, because, for example, flipping the order of two matrices does not mean that it will work. So if we have 3 by 4 times a 4 by 2, this is correct and it gives us a 3 by 2 matrix. But if we flip, so this is matrix A and this is B, if we flip them and do B times A, we're going to have a 4 by 2 matrix times a 3 by 4 matrix. We cannot do that. So multiplication is not necessarily the same with matrices as it is with most things. So the associative property of matrix multiplication tells us that if we have AB times C, this will equal A times BC. Okay, so if you have 3 different matrices and you keep them in the same order, but move around which ones you multiply first, that should still give you the same answer. But notice these stay in the same order. The associative property of scalar multiplication says that K times AB, so K would be your scalar, is the same as K times A times B, or also A times K times B. So you can have the scalar after you multiply the matrices together, or you can multiply the scalar by either of the matrices before you multiply it with the other one. Notice that A and B stay in the same order every time. The K is free to move around, the scalar can move around, but A and B have to stay in the same order left to right. The left distributive property, so this says that C times A plus B is equal to CA plus CB. So if you have a matrix outside of two matrices added together, you can distribute that matrix out. However, there is a right distributive property because the order that you multiply matrices matters. We just talked about that in the example I gave you before we started the chart. On these, you can still distribute, but the C is on the right side, so that means that the C stays on the right side. And the last example I'm going to walk through with you is an application problem. So we are actually going to look at a real world scenario where we can use matrices besides to get a good score on the ACT. It says the first table shows the number of reams of paper, packs of dry erase markers, and boxes of staples requested by 2 teachers. The cost per item is given in the second table. Use matrix multiplication to show the total cost of supplies for each teacher. So I'm going to show you how to do this in just a second, but first I want us to think about the fact, if we wanted to know how much Mr. Smith spent, we would do paper times paper cost, we do markers times marker cost, staples times staple cost, and then we would add those together. Well, that's exactly what we do whenever we do matrix multiplication. So if we turn this chart into a matrix, so 6, 8, 4, 2, 5, 3, and then we turn this into a matrix, we can multiply them together and it will be the same thing that we were just talking about doing. It is important that this is paper, marker, staples, paper, marker, staples. They need to be in the same order, even though this one is a column and these are by row. So this is a 2 by 3 matrix times a 3 by 1 matrix. We can do this, and it's going to equal a 2 by 1 matrix. So to find row 1, column 1, we multiply the first row times the first column. So this is exactly what we talked about doing. We're taking the amount of paper that Mr. Smith bought times the price of paper. So 6 times 15 is 90. Then we're taking the number of markers he bought times the price of markers and adding that to the price of paper. He bought 5 packs of staples at $2.50 each. That is a cost of $12.50, and we will add that to the other costs that he has. So now to get row 2, column 1, we will do her paper times the cost of paper, which is $120. Then we will do her markers times the cost of markers, which is $8. And finally, her staples times the cost of staples is $7.50. And when we add each row, we're going to get 118.5 on the top and 135.5 on the bottom. And these still correspond to these teachers. So, Mr. Smith spent a total of $118.50, and Mrs. Wills spent a total of $135.50. So this is our final answer for this problem. Thank you guys so much for listening, and I hope you have a great day.